Welcome to listen our expert talk on how data can help enhance resource efficiency. My name is Antti Komulainen. I'm a data analyst at Raute.
And my name is Janne Pirinen. I'm a product manager at Raute. Hello everyone. Antti will talk about long-term data usage in more detail later. But first I will say a few words about collecting and utilizing data in real time. In today's data-driven world, the importance of collecting correct and accurate data is paramount. In plywood production, data accuracy is essential for optimizing processes, improving quality, and reducing costs. But it also plays a vital role in enhancing sustainability. When we collect data, we enable real-time monitoring. No data, not much to monitor. This allows us to track production processes, optimize resource allocations, and adjust them as needed. In addition to machinery-related data, which helps us to fine-tune our preventive maintenance schedules, we have analyzers throughout the mill, from XY chargers to panel repair lines and everything in between. These analyzers collect data from incoming material, raw material if you will, and make instantaneous decisions based on measured characteristics and set grading rules, thus making sure that every piece of veneer ribbon, every veneer, and every panel ends up in the right location for the next step of the process. The importance of accurate data is obvious when we are making decisions that control the material flow within the mill. With accurate data, data-driven decisions to minimize waste, reduce energy consumption, and promote sustainable practices are made easier. This is where Raute's AI-enhanced R7 series analyzers will give you increased accuracy and precision compared to traditional non-AI analyzers. For example, in peeling lines, veins, rounding errors are detected as a whole instead of multiple small chunks. Our microwave and X-ray sensors will give you accurate moisture and density measurements there as well. In drying lines, precision of knot detection, resin pockets and harvester marks are significantly improved. All this, integrated with our moisture and strength analyzer, paints a comprehensive picture of your dry veneer stock. In composing lines equipped with our AI systems, this increased accuracy allows us to minimize operator involvement, maybe even remove the operator altogether. So no more ripping of pieces of veneer or marking defects with a pen or paint. Patching lines, well, that's where every millimeter or tenth of an inch matters. So again, the increased precision of AI systems on defect size detection will give you the opportunity to make grading decisions with confidence. In panel repair lines, we can utilize AI to filter out glue stains present after layup and pressing. No more excess repairing. In conclusion, collecting correct data and making sure that the data is accurate is the first step for us to optimize processes, improve quality, find causal relationships, and reduce our environmental impact. Thank you for your attention. Now, Antti will take over and tell you more about the next step, utilization of long-term data in practice.
Thank you, Janne. So, how to put the data to work? Automated processes generate a lot of data. A veneer dryer can process 1 million sheets per month. From each sheet, you can track dozens of measurement points. Recently, the usage of grading data has been increasingly gaining popularity at mills. Grading data is one of the 3 data packages we have in Raute Millsites data collection and reporting system. Best mills have had the basics in place for some time when it comes to utilizing data. The most advanced are also having dedicated people working with the data. Now it's time to put the focus on grading. For the most part, visual grading takes place right after the drying. Following closely the grade distribution trend is very important for maximizing the share of the most valuable veneer. Any changes in the distribution has immediate effect on profitability and resource efficiency. In this simplified example, let's look at a grade distribution trend. We can see the share of composer grade increasing. To understand better the reasons behind, we can use the critical defect statistics available in mill sites. For each sheet, there is a data available for what was the main reason causing the sheet to be graded in the lower quality instead of more desired higher quality. So, we are interested in why the composer share is increasing. By filtering the critical reasons for this grade, we can see the issue is with too long splits. Then we can start checking the process backwards. Were there any abnormalities in the drying conditions that caused, for example, overdrying and splits? Similarly, there are obvious things to check from peeling and log conditioning data, which can correlate with splits. You might find a small change there, and by fixing it, you get the grade distribution back to normal. Then, what if the root cause is not in your hands at the mill? Let's say a change in raw material. You must now work with what you get. Here, rear-view mirror to previous processes doesn't help much, but you can still have a look at the following stages. So you have sheets with a little bit longer splits. What happens if those were not sent to composing? Could the sheet hold together all the way to layup station? How much bigger share of full sheets you would get in that case? The visual quality grades itself are fixed. You cannot make compromises on those. But how is the limit being defined for a split that sends a sheet to composing? Is this based on fact that the sheets are breaking down in layup-in feed? If not, you might be able to increase the safety margins on split length and still get it in one piece to the finished product without compromising on quality. This is a very difficult and risky trial to do in real production. It also takes a lot of calendar time to verify the results. That's why the grading data package in mill sites comes with a scenarios tool. With that, you can do test runs offline. This means you'll use your actual sheet data and you see how your grading distribution would have been if you'd allow a little bit longer splits. You can run different scenarios with any defect type and see what the outcome is before you do any changes in real grading parameters at the production line. All this happens in a fraction of the time compared to what it would take in real production to do the test. In real life, it might not be as simple as this example, but I think you got the point. Long-term grade distribution trend and scenarios runs can make a big difference. It is a significant enhancement on resource efficiency overall. This is how the fastest developing players run their mills, and the results speak for themselves. Thank you.